If you'd like to learn how to create raycasts that identify parts in the workspace and make changes to them when you click on them with your mouse, keep watching and I'll show you exactly how to do it. Welcome to Roblox Snippets. In this video, as I showed you in the demo at the beginning, we're going to learn how to use raycasting in Roblox Studio to change a part's properties and identify things about that part as well. So just before we begin on the coding, we'll create a part in the workspace. So come up and click on the Home tab and then come over and click on Part, and we will change just the size. So if we scroll down, and we'll change the size to be, say, 6 by 6 by 6, and then we'll move that up so that it's just sitting on the base plate. And we'll also just scroll down and make sure that anchored is on and can collide is on. Now we will we'll make this part 1, and then we will duplicate this. So you can make a copy by either right clicking on it and coming up to duplicate, and then once you've duplicated it you can drag it across, and we'll change it to part 2, and we can also duplicate there and move that across, and we'll put it over there, and that could be part 3. So we've just got some parts to work with once we do our coding. Alright, so once you've got some parts in here, now when we're dealing with raycasting, this is happening on the client, so we need to use a local script, and for that reason it needs to occur in local scripts will only work in certain folders. So anything with server in its name, it won't work in there. Also won't work in the workspace. However, it will work in the starter GUI, the starter pack, which becomes our backpack, and these two folders down here, starter character and starter player. And in this case, because we're going to deal with the user input of the mouse, we'll click on starter player and come over and add a local script. Alright, we can go ahead and remove the print hello world from our local script, and we might just change the name of this over here to be our user input script. Alright, we changed the name of this to user input because that's what we're dealing with. Our mouse, you see my cursor moving around, that's me as a person moving the mouse, inputting something into the computer that allows us to do something. So we use a special service called user input service. So we'll create a variable for that, UIS, which will be equal to game, and get service user input service. And it's responsible not just for the mouse, but also when you press keys on your keyboard and other things as well. So it has special methods built in that let us manage those things. And one of them is to get our mouse position. So if we create just down below here a mouse position variable, we can say equals user input service and then a colon, and use the special method called get mouse location. So when that pops up, you can go ahead and hit enter. So this will run, if I run the game immediately, we can print that out if we wish. So let's say we put in here print and our mouse position. You can do this or just watch if you like. If I run the game now and I move my mouse here, and once the script runs, you'll notice that two numbers come up down the bottom here. And that represents our mouse position X and our mouse position Y. Now, if you're familiar with moving around in a 3D environment, you might think, oh, Y is up and down and X is left and right, okay? And then Z moves up and down. But in this case, our mouse position is moving on a screen. So it doesn't have 3 dimensions, so it's only X and Y, all right? So, but the other problem that we have here is that it's only captured it once when the script runs. And we want it to constantly check where the mouse is. So we can come up and click stop, and return back to our script here. Alright, so in order to capture our mouse position over and over, we're going to make use of another service. So just below our user input service, create a variable called rs, and this is short for run service. which will be equal to game, get service, and then inverted commas, and run service. So the run service runs allows us to check or run code very quickly, constantly. And the way we can make use of that is to say run service dot, okay, rendered step. Now, rendered step, you'll see this little lightning bolt here, okay, and this is going to fires every frame prior to the frame being rendered. All right, so it's firing very quickly, which lets us connect a function to that. So connect, and then a function, and allows us to do something inside of this function every frame. All right, so it's running very quickly. So if we were to move these two lines, so highlight these, right click and cut them, and then click inside of our function and right click and paste, we can now run this, and it should now update very quickly where our mouse is on the screen. So you'll see if I just stay still, the numbers are increasing very quickly, and if I move my mouse, it's updating our mouse wherever it is on the screen. All right. Right up the top left is the smallest numbers, and then moving down, right down here, we get to the highest numbers. And in the middle, if it was square, then they would become almost equal. Okay, so we'll stop that, and we've got a way now to find out where our mouse is. Now, our mouse is one part of creating a raycast. The other part is to make use of the game's camera. So if you look in the workspace, you'll see it comes with a camera. And on the client, we want to make use of each client's camera to draw an imaginary line from where the mouse is into the game world. So for example, if my mouse is sitting here, and let's say it was 945 and 122 here, we then create a raycast from here to whatever I'm pointing it at. All right, so up here, if I move over the top, it's drawing an imaginary line into the game world to this part. All right, so, and that is what, or essentially what a raycast is. So to do that, we'll need to get access to our camera. So we'll create a variable camera, and to get access to it, we'll say workspace.currentCamera, and that will let us make use of the camera. So for now, let's just move down here, and to handle creating our raycast, we're going to create a function. So local function and create raycast. So there's a couple of parts to creating a raycast, and one of them will be our mouse position. So we'll actually take this and we'll right click and cut that and put it inside of our new function, and we can get rid of our print mouse position there at the moment. Leave this part here though, because we will make use of that. So the next thing is to create a raycast using our mouse position. So we'll create a variable called raycast, and it will be equal to, from the camera, we want to use a special method which is called view point to ray. And you'll notice here creates a unit ray from a position on the viewport in pixels at a given depth from the camera. So it's going to make use of the X and the Y of the mouse to create a ray into our 3D world. So we'll put in here mouse position dot X and then a comma, and then mouse position dot Y. Right, and it's got an optional one here, but we won't worry about that. This is all we need at the moment. I'll just get rid of these so you can see the whole line. So this will create a raycast and return something to us, and we want to capture that result. So we'll create a variable called RC, so raycast result equals, and then we'll say workspace. So this is where we want to create the raycast, and then a colon, and we'll use the method of raycast, which asks us to put in these things here. So the origin casts array, so this is casting array, and we're going to make use of this variable that we just created here based on our camera. So in here, it's looking for the origin. So we'll say raycast dot, and you'll notice that we get what it is asking for. So we can simply double click or hit enter to get our origin. And then the next one is, we put a comma, is the direction. So we'll say raycast dot direction. Now, when it says direction, you can also specify by multiplying this by a number, and we'll say 200, and this represents the number of studs that the raycast will go out into the game world to before or try to hit something. So if it gets to 200 and it hasn't hit anything, then it won't return. So you can make this bigger, or you could make it smaller depending on what your use was, but 200 will serve us well. And the last thing that we need to do is simply return this result. So we use the keyword return and RC result. So each time this function is called, it'll run through all of this, create a raycast, and return the result to wherever it was called. And we will now make use of our rendered step down the bottom here to make that happen over and over again. So inside of here, we'll say local, and we'll create a new variable just called result, and it will be equal to, and we're simply going to take a copy of this to call our function, copy and paste it here. And so this will be running and returning the result to here. Now what we want to do is firstly have a conditional statement to say if there is a result, all right, and we're going to say if the result is an instance, then. So an instance is a copy of something, basically something you can see, like this part or these parts, the base plate, this here, and that way if it's moving around and it's not hitting anything, then it's going to skip this code and not run what is inside. And in this case, we will simply put in here initially print the result.name. Actually, we'll just put in result and you can see what gets returned. So if you've got your code looking like that, then come up and click on play. And you should notice down the bottom here, you're getting these, and we'll just stop it because it'll keep doing this over and over. But it's returning all of this information to us, all right, based on our raycast. So if we have a look at one of them down the bottom here, I actually hit part 2 here, and then it said it's at this position, and then we've got some other information, and we've got the material. So it's giving us all this stuff that we can make use of once we have this information. But this is a bit confusing, so let's change this now. Instead, let's change this to just say name, and that way we're only getting one piece of this information. And if we run this again, oops, sorry, my apologies, we really need to put in here the result.instance.name. Okay, and let's see if we can get that to run. Alright, so now if I move my mouse, you'll see I'm pointing at the base plate, and if I move over here, I'm now on the spawn location, and if I move up here, we've got part 2, we've got part 1 over my head, part 3, and if I point at my character, we're getting the parts of my character. Alright, so if you've got it working like this, then everything is working well up to this point, and you can go ahead and stop. Alright, so now we're going to do something with the information that we are getting from our raycast. So back into our script, we're going to create a new variable because we want to save whatever the instance is to a variable so that we can do something with it. So just come back up to the top of your script here, and we'll create a new variable called item, and we're going to set this initially to nil. So nil is just nothingness, it just doesn't mean anything. But then down inside of our rendered step here, instead of printing the result.instance.name, we're going to assign, so we're going to say item equals result.instance. So the item will become whatever it is that we are attempting to work with. And we can still add our print in here, but now we can just say item.name, and that will print out the bottom here what it is that we're working with. Okay, so next what we want to do is, if we are on an item, we want to do something, and to do that we're going to make use of another part of the user input service which allows us to handle mouse clicks. So just below where we created our function, we'll say user input service and then dot. And the way we capture input is to say input began, which means a key is being pressed, and the computer says, okay, what do you want to do with that? And in this case, we want to connect a function, and we add two parameters in here. The first one is input. So as you can see in the helper text here, it's expecting what is it that, or what is the actual input, so which key is being pressed. And the second one, if we hit this, is a Boolean, which we're going to call busy. Now, and we'll just finish that, so move out there and hit enter. So what this busy is for instance, in the game, if you had said press Y to open the chest, alright, so the player's pressing Y, however they then get a text, a chat message, and they click on the chat box and they're typing Y, then it will say that it's busy and decide that, well, we don't want to trigger this code because it's being used elsewhere. So basically that's what this is for. So it stops those sort of errors from happening when you're doing other things like typing in chat. Alright, so inside of here we know that we've got some input, and the next thing we want to do is decide what it is. So we use a conditional statement and we say if input dot user input type. So we want to find out what type it is. And if that is equal to, and we'll use Roblox's built-in variables by saying enum. Right, so these are special things we can use to check against. Enum dot user input type dot, and in this case mouse button 1. So we want to know if the player is clicking on the mouse and not busy. So that means they're not in chat or doing something else. So if that is the case, then we will let this code inside here run. And this is where we'll make use of our new variable here. And we want to know, well, is the item an instance that we can do something with? So we'll create another conditional statement to say if item, and then a colon, and is a, alright, open brackets, and then our inverted commas, and a base part. So if the item and then the method is a base part, so it's going to check for us if this is something physical in the game that we can click on, then we can do things with that item. So in this case we'll change the item's color. So we're going to say item dot color. So this is a little, it's not brick color, it's the color equals color 3 dot new. And now you can use combinations of red, green and blue to create a color. So if we were to put in here 0, 1, 0, then we get green. And if we were to put in here a 1, we get blue, etc. So you can play around. You can put the numbers in, or you can click on the actual wheel here and pick the color that you want to change it to. So if I wanted to make it this sort of orangey pinky color, then I could click on that. Okay. And when we click on the part, this is what's going to happen. Now you can also change the part's material, etc., or do other things as well. But that is enough for us to give it a test. So let's click on File and Save and see if that works for us. Right, so as you can see, I'm moving around my base plate and I'm on the spawn, I'm on my parts. I haven't clicked the mouse yet. So let's say we move over part 3 and I click and the part changes color. I move over here to part 1 and I can now click on any part and change, if it's a base part, change the color, even onto my head and parts of me. Well, I have to be fairly good to click on those to click these, but if it's a base part, then it will affect it. Alright, so that is a very basic understanding of how to make a raycast, and I'll just bring up all of the code there so you can see it. But that's how to create a basic raycast and make use of some of the information in here to do things with. All right. And there are many other uses and things you can do with Raycast, but hopefully you will come up with much more interesting things to do than what I've shown you here. And I will be covering more things in future videos that make use of Raycast. So I'll see you in those videos. If you found this video useful and would like to learn more about my online courses, go to mrbrendanross.com.